We're going to use the new Vernier high current and higher voltage sensor today. And we created this specifically for this environment, for maybe testing solar panels or doing some alternative energy, things like that with a small windmill. And so I'm going to use these two together. And what I have is a photovoltaic panel here, and then I'm going to run a motor. This is just an old electric fan from a car, so it's a 12-volt motor. And I can drive the motor with the photovoltaic panel, and I can measure the current and I can measure the voltage simultaneously and then calculate the power produced by this. And so that's the kind of thing you would end up doing with this sensor. The high current sensor, it is a Hall probe for measuring current up to 10 amps of current. So you don't want to go above that, you could damage the sensor, at a maximum of 40 volts. And so for that one you want to keep it in those ranges. And again, for something like this with a photovoltaic panel, it's kind of perfect for that one. And then this is the 30-volt voltage probe. And this panel produces about 18 volts open circuit, so it should be fine for this. And so what I've done is I have this wired up so that I have the current sensor wired in series with the motor. And when I attach the wire, it's going to allow the current to flow. We can measure the amount of current. And simultaneously, I've attached the voltage probe across the load, in this case would be the motor. And as the motor starts to turn, we can measure the power. I'm going to plug in my sensors, and so they're both analog. So I'll plug in a current sensor into channel 1, my voltage probe into channel 2, and I'm getting readings close to 0. I don't have my circuit connected right now, so that should be fine. And one of the things about doing work with this outdoors is that the LabQuest has a new high contrast screen that makes it easier for us to see what we're doing outdoors. And so I'm going to actually change this. And so if I go under the house icon there, click there, I can go to the preferences, and then under light and power, I click there. And then down in the lower left-hand corner, I have high contrast. And so if I check the box for high contrast, then I can close that out. And you will see that it will actually change to a black and white. It makes it much easier to see when you're out in full sun. So at this point, I'm going to be ready to collect my data. And before we do that, though, let's take a look at what we're going to be collecting. It says up there, mode time-based. So we're going to look at current and potential as a function of time. 10 samples per second, that's fine for what we're going to do in 15 seconds. And so that will be fine. So what I will do is I'm going to start collection first, then I will connect the circuit. So I'm going to attach the wire to the current sensor to complete the circuit, and we'll measure the current and potential together. And then we'll come back and do a calculated column of power. So at this point, I need to hit collect. There we go. And I'm going to attach my wire. And as soon as I do that, there we go. So now we have some data, and at this point we could take a look at it. And at first we see, well, when I was attaching the wire here, I kind of attached it and unattached it, so we had a little bit of a little bobble there. And here we see that the current jumps up here. The voltage actually begins to increase a little bit as the motor begins to spin up. We end up with a little bit of back EMF, and at some point it kind of reaches a maximum up here. It takes a few seconds for it to be able to get up to full power there. Now at this point, what I might want to do is actually look at my power produced by my panel. And so to do this, I need to do a calculated column. And when I do the calculated column, I need to do that from the data table. So I'll go up and open up my data table. And then under table, I can do new calculated column. So I'll go there. And what I want to do is multiply the current times the voltage. That ends up giving me power with the unit of watts. And so at this point, I'll come in. I will rename that. And so I'll rename this power. And done. And my units as watts. And watts. Done. So I have my name and my units there. Now I need to do my equation. So my equation that I want to be able to multiply the current times the voltage. So I need to go down here and find where it says XY. So I'll just slide down here. And so there we go with XY. So I'll select XY. And then it comes up here and it says, well, what's X? And it's defaulting for it to be time and the Y to be current. Well, I don't want that to be time. I want that to be potential or voltage. And so I'll come here and tell it to be potential. So now I will, when I hit OK, it will multiply potential times current and will give me a graph there with the watts. Now, here's what I want to do here. I want to show just one of the graphs, and I want to make the graph be the power here. And so I'm going to go to Graph, and I'll do Show Graph 1. And right now it's doing power in terms of watts in terms of time. And so we see at first there's my little bobble when I'm connecting the wires, and the power production begins to increase, and it peaks up here someplace. So I might want to actually do some analysis. I could just come over here and maybe examine, and if I do that, it tells me what's the power production there, 9 watts up there. So I'm getting about 10. I could, at this point, come in and actually do, under Analyze, go and run my statistics. But maybe if I want to find out what was the maximum power production, and so I end up with about 12 watts there, and when it does that. So again, the high current and 30 volt voltage probe is an excellent probe if you want to study alternative energy with photovoltaic panels or windmills. And so it is definitely a good option for doing those kinds of experiments.